All right, so for this particular video, we're going to go through, deal with inverse trig functions instead of just trig functions. But we're going to go through and figure out if I know what the ratio is, can I determine what the angle is? And we're going to do that through radians. I know your applications with everything that you've done in the past has been with degrees, but really they're only defined, the inverse functions are only defined through radians. So we're going to work strictly with radians. So let's deal with the very first one. Our very first one deals with determine the exact value of the inverse tangent of the square root of -3. So I like to start by going through and graphing what this would look like, meaning just the tangent function. And I base my work off of that. So I'm going to draw a tangent function. Or I'm going to try to draw a tangent function. All right. And we know that we have our asymptote line at pi divided by 2 on the x-axis. And then we've got the other side at negative pi divided by 2. I'll choose a different color just for the graph itself. So we start here at 0, 0, and then we curve ourselves up, and then, and then we are bound by the asymptote line. And then we go this way and down. And we're looking for where is it negative square root of 3. So if we were looking for where is it positive square root of 3, you got to remember that it's 1 right here in the middle, which would be at pi divided by 4. Square root of 3 is larger than 1. So therefore my smaller value would be here, which is square root of 3 divided by 3. And my larger value would be here, which would be square root of 3. Now, obviously, I don't want positive square root of 3. I want negative square root of 3. So this location here, I'm going to draw an arrow just because there's not enough space. This would be located at pi divided by 3. So tangent is an odd function. So therefore, I can go through and say, all right, well, in an odd function, it's just the opposite of the tangent of square root of 3. But I can also visualize it doing the same thing. So if here, this is, again, I'll do an arrow because I don't have a lot of room. Negative pi divided by 3 is where I'm going to be at negative square root of 3. So again, we're using our information from what we already knew to try to figure out what the inverses are. So here's again another opportunity where I have to say, knowing your trig values and knowing the angles that go with those trig values is what's going to make this more efficient and quicker for you. So again, then that means that the inverse tangent of negative square root of 3 is equal to negative pi divided by 3. So again, what they're doing is they're giving us the trig value, and we need to determine the angle. And our angles are in radians. All right, next example. So for this one, determine the value using a calculator. Arc sine of 5 over 12. All right, so you're sitting there thinking, why are you going to show me how to use a calculator when all I got to do is just type the information in? But what I want to point out is that arc sine is the same thing as saying sine to the -1 or inverse sine of 5 divided by 12. Now, if you just use the calculator and all of a sudden you got the answer was 24, like you typed in inverse sine 5 divided by 12, it'll give you 24. But the problem is that this is not right because that's in degrees. Remember, we're not looking at degrees. We are only dealing with radians. So you need to make sure that you are in the proper mode. So make sure calc is in radians. Okay, it has to be in radians when you go through and do these in our application. So then in that case, that means, all right, fine. So I'll take the inverse sine of 5 divided by 12. I'll use my handy dandy calculator right here. And I end up with equaling 0.430. And that's in radians. We don't have to find the exact value. This is not one of those that we would remember because if you look at this, this is not one of the ones that we're used to seeing. So Just use your calculator and make sure you have it in the right mode and understand that arc sine, arc cosine, arc tangent, it's the same thing as sine raised to the negative 1. All right, so this next one, determine the exact value without using a calculator. We're going to go through, I'm going to draw like we have before. I'm going to draw the cosine first, because I know I'm going to need the cosine function. So cosine starts at its high point, comes down, crosses, hits its minimum, crosses again, hits its maximum, and then we'll go backwards too, because it's always good to get a full cycle in this sense. All right, this could continue if I wanted to, but I also have to move it back because it's asking at negative pi divided by 2, what is the value of cosine? So again, this is the cosine function. All right, so this is saying, what's the cosine of negative pi over 2? Well, here's negative pi over 2. The value of that is 0. So I'm going to go through and replace the information that I just found. I'm going to substitute. So I'm going to start my writing over here. Sine of negative 1 of the cosine of negative pi divided by 2. So we just found the inside set of parentheses, because remember, order of operations, you got to do the parentheses first. So let's deal with that first. So then that means, all right, fine, the sine inverse of 0. That's what is now left. So now I'm going to go through and I'm going to draw the sine function. Well, I'll even put it here as I'm labeling it so that we don't lose track of where I'm at. And sine starts at 0, 0, comes up, hits its high point, crosses again, hits its low point, crosses, and then I'll go backwards. Like I always like to go back a negative pi over 2 as well. All right, we know this out here. This is 2 pi. Here's pi. Pi divided by 2, and then lastly 3 pi divided by 2. Now, inverses, remember that for sine, and we did this part in class, the sine, its inverse only exists here. Oops, didn't write. Come on, right. There we go. And here. So the inverse is going to exist in this interval only. All right, so in that interval, where is sine going to be, or I should say, what is the trig value when the angle is, got that backwards again. What is the angle when sine is 0? Okay, because remember, in this we expect as an angle. When I deal with the inverse, this is the trig value. Right? I should have said that first to prevent any confusion and also to prevent my own brain from being confused. So now, as I go through, I'm looking to figure out, okay, what is the angle when sine is actually equal to 0? And this is going to be 0 because I'm looking at the point right here, 0, 0. So this is 0 radians. All right, let's go to the next one. This one is a little different. Okay, determine the exact value without using a calculator. But the problem is, you gave me 4/5, Maine. What am I supposed to do with that? All right, so we're going to go through and we're going to draw this out. This is like the stuff that we did with the triangles. So notice, oh, we're missing something here. My bad. I'm going to rewrite this because this doesn't make any sense the way it's written. So it's actually a good error. It's always good to make errors because then they turn into teaching moments. Yes, I did it on purpose. At least that's my story, and that's what I'm sticking to it. All right. It should read that this is a -1 for my exponent. So what I'm doing is I'm trying to find the inverse sine of 4/5. And then I need to figure out the cosine of whatever that comes out to be. So let's think about this. This right here is going to give me an angle. Then when I take the cosine of an angle, I get back to a trig value. So I don't really care what the angle is. So angle part, who cares? Seriously, who cares? Nobody's going to care what the angle is. All right. What we need to figure out is just what is the ratio of the cosine of that angle. So we're stuck in a triangle, and we can go back to our work in the unit circle. All right, so inverse sine. Inverse sine only happens in quadrant 1 and in quadrant 4. There's no inverse sine out here, so these are useless. When is the inverse sine going to be positive? Well, the inverse sine is going to be positive in this quadrant. It's negative in this quadrant. So what that does now is it tells me I've got a triangle that's going to be in the first quadrant. All right, so this is the angle, and I don't care what the value of the angle is. I'm just using it as a reference. So sine is opposite over hypotenuse, so that means this side is 4, this side is 5. We should be able to know this other side. We should be able to know the adjacent side because either we go through and use the Pythagorean theorem, a squared plus b squared equals c squared, or hopefully this Pythagorean triple is starting to be stuck in your mind whether you want it there or not. So the Pythagorean triple of 3, 4, 5 is a right triangle, a 3, 4, 5 right triangle. So now all we're looking for is this right here helps draw the triangle. Helps me figure out where I need to draw the triangle. So that's where I am. Now I want the cosine inside this triangle. All right, so again, I don't care about what the angle is. It's not going to help me any. It just helped me to try to create this. So now when I go to simplify, all right, so the cosine of the inverse sine of 4/5 is equal to, all right, well, what's the cosine? Well, cosine is adjacent side divided by the hypotenuse, so it's just 3/5. All right, so again, just to be a little bit of a refresher, we use the inverse part to figure out which quadrant I'm going to draw in. All right, and then once we figure out what quadrant I'm going to draw it in, then we'll work from there and figure out what exactly is cosine. All right, in this case. So we draw our triangle and then figure out cosine. All right, so I hope that this was helpful, useful, or whatever else that you need so that you can remember how to deal with inverses. Again, my name is Robert Main, and I am a Charahoe. I am a teacher at Charahoe. I guess you could say I'm a Charahoe because I went to school here, but teacher at Charahoe Regional High School, and I appreciate your time in watching this video. Thank you. Have a great rest of your day.